Good morning students, class 10th. Today I am going to discuss the next remaining reactions of metals. That are fourth reaction of metals with chlorine. Fifth, reaction of metals with hydrogen. When metals combines with chlorine, they form respective metal chloride. When metal combines with chlorine, they form respective metal chloride. For example, when sodium combines with Cl2, it forms sodium chloride. When calcium combines with Cl2, it forms calcium chloride. And when magnesium combines with chlorine, it forms magnesium chloride. Less reactive metals such as iron, zinc, aluminium, copper, they also combines with chlorine, but the reaction is very slow at room temperature. Therefore, these species reacts with chlorine only on heating. Clear? The reactive metal like sodium, calcium, magnesium combines with chlorine at room temperature. Metals like aluminium, zinc, iron, copper, they combine with chlorine only on heating because the reactivity of these metals is quite less as compared to sodium, calcium and magnesium to form the respective chloride. Next is reaction of metals with hydrogen. Generally the metals do not react with hydrogen. Only the highly reactive metals such as sodium, potassium, calcium, magnesium, they combine with hydrogen to form the respective metal hydride. When Na combines with H2, it forms NaH, sodium hydride, followed by heating. These reactions are generally formed by passing hydrogen gas over the heated metal. So, in this case, heating is also required. Next is reaction of metals with salts. Reaction of metals with other metal salt. This reaction is generally named as displacement reaction, in which more reactive metal displaces the less reactive metal from its salt solution. We have already discussed this reaction in chapter 2. Next is reducing behavior. Metal shows reducing behavior, and this reducing behavior of metal can be explained. As we know, metal can easily lose electrons. Therefore, we can say that metals will behave like reducing agent. Therefore, metal behaves like reducing agent. For example, sodium metal combines with chlorine. It was observed that this sodium metal reduces this chlorine to respective chloride and form NaCl. Clear? In this reaction, when sodium combines with chlorine to form NaCl, it was observed that this sodium metal loses electrons. It means this sodium metal reduces this chlorine to respective chloride. Therefore, this metal will act as a reducing agent which oxidizes itself and reduces the other. Clear? Next is the reactivity series of reactions of metals with solution of other metal salt, also named as displacement reaction. It is also called as activity series or reactivity series of metal, or the reaction of metals with other metal salt solution, also named as displacement reaction. In such reactions, it was observed that a more reactive metal displaces less reactive metal from its salt solution to form the salt solution of reactive metal, and with formation of metal B. Clear? All these reactions have been already explained in chapter 1st as well as chapter 2nd. So the first reaction is reaction of zinc with copper sulfate. This reaction can be explained if you have learned the reactivity series. Now, on the basis of reactivity series, we know that this zinc is more reactive as compared to this copper. Hence, this zinc displaces this copper from its salt solution, resulting in formation of zinc sulfate with evolution of Cu. So, this zinc displaces copper from the salt solution because this zinc metal is more reactive and this copper is less reactive on the basis of their position in the reactivity series. So, formation of zinc sulfate and copper will take place. During this displacement reaction, the reaction is said to be exothermic in nature, and the reaction will take 10 to 15 minutes for completion, and in this reaction always there will be a color change. Hence we can say that in this reaction change in color takes place. For example, this zinc is silvery metal with bright appearance, and this copper sulfate solution is blue in color. When they undergo displacement, formation of zinc sulfate takes place. As a result, the blue color of solution changes to colorless. Clear? The blue color of solution changes to colorless, and this copper will be deposited by reddish brown color. Clear? In this way we can explain all the different kinds of displacement reaction, that is reaction between copper and silver nitrate, reaction with iron and copper sulfate. Next is why some metals are more reactive and other metals are less reactive. Now in this reaction, suppose we have explained that zinc metal is more reactive, and in this salt solution this copper metal is less reactive. Why zinc is more reactive and why copper is less reactive? So this reactivity can be explained. The metal are the elements which lose electrons and form the respective positive ions. Clear? Metals are the element which loses electrons and form the positive ions or the cations. The more easily a metal can lose electron, the more reactive it is. Clear? The more easily metal lose electron, greater will be its reactivity. तो जो भी मेटल है हमारे पास, जो भी एलिमेंट है, वो जितना फास्टली इलेक्ट्रॉन्स को लूज़ करेगा उसकी रिएक्टिविटी भी उतनी ही ज़्यादा हाई होगी. सो इन दिस केस जिंक अंडरगो फास्ट रिवॉल्यूशन ऑफ इलेक्ट्रॉन्स एज कम्पेयर टू कॉपर. दैट्स वाई जिंक इज़ मोर reactive and copper will be less reactive. Second is why some metals are more reactive than hydrogen and some are less reactive than hydrogen. It can be explained by considering the example of reaction between zinc and sulfuric acid or hydrochloric acid or any kind of dilute acid such as H2SO4 or HCl. Clear? It can be explained by considering the example of this metal with H2SO4. Now how can we prove that this metal is more reactive than hydrogen? And some metal like copper, when combines with H2SO4, no reaction takes place. In this case we write here that no reaction takes place. Why reaction doesn't take place? Because in this case copper is less reactive as compared to hydrogen. So it can be explained as the metal which loses electrons more easily than hydrogen. In this case we compare the reactivity of metals with hydrogen. So the metals which lose their electron more easily or more quickly, as compared to hydrogen, they are said to be more reactive. In that case the metal undergo displacement reaction with acid and displace hydrogen gas. तो उस केस में H2 को वहाँ से क्या कर देगा, displace, resulting in formation of salt solution of metal with evolution of H2 gas. In this case hydrogen gas is evolved. But when copper combines with this sulfuric acid, hydrochloric acid or nitric acid, it was observed that this metal is now unable to lose electron more fastly as compared to hydrogen. Clear? In this case the metal which lose electrons less readily or less easily then hydrogen are said to be less reactive. It means इस केस में जो ये स्पेसिस है हमारे पास hydrogen of the acid, it loses electrons more easily as compared to copper. Therefore it is more reactive and this is less reactive. Hence in this case no reaction will take place. Next is the chemical properties of non-metals. We will start the chemical properties of non-metals, and we know that non-metals are electronegative in nature because non-metals acquire negative charge by gain of electrons. We know that non-metals acquires negative charge by gain of electrons. Suppose we have Cl having 7 electrons in the valence shell. This shell can be completely filled if this chlorine acquire 1 more electron or gain 1 electron and becomes Cl negative. So it means this chlorine is a non-metal which acquire 1 more electron to complete its octet to acquire the noble gas configuration, thereby acquiring the negative charge. That's why these species or such kind of elements are considered as non-metals, and by gain of electron they will acquire negative charge, undergo formation of anions. So that's why the non-metals are said to be electronegative in nature, while metals which loses electrons and acquire positive charge, they are considered as electropositive in nature. Now first is the reaction of non-metals with oxygen. Reaction of non-metals with oxygen. When non-metals combines with oxygen, they result in formation of oxides. One is called as acidic oxide and other is called as neutral oxide. So when non-metals combines, they form two types of oxide named as acidic oxide, and second is called as neutral oxide. And we have also discussed about reaction of metals with oxygen, which forms basic and amphoteric oxide. Clear? Now the non-metals such as carbon, when combines with O2, resulting in formation of CO2. This CO2 is said to be acidic oxide, and this nature can be checked when we dissolve this carbon dioxide in water. When we dissolve this carbon dioxide in water, it results in formation of H2CO3, which is named as carbonic acid, and this solution of CO2 in water will changes the blue litmus paper into red, indicating that this CO2 is again acidic in nature. Clear? That's why this CO2 is called as acidic oxide. Same nature is shown by oxides of sulfur and phosphorus. Some oxides of non-metals which neither reacts with acid or bases, they are called as neutral oxide. There are some other oxide which neither reacts with acid or with bases. Such type of oxides of non-metals are said to be neutral, and in such cases the litmus paper also doesn't show any kind of change. Means these compounds neither turns blue paper into red or red into blue. Examples are formation of carbon monoxide, formation of nitric oxide, and formation of water. These oxides of non-metals are neutral in nature and formed by combination of carbon with oxygen, combination of nitrogen with oxygen, and combination of hydrogen with oxygen, resulting in formation of these different kinds of oxides. So these oxides are said to be neutral. It means their aqueous solution or their acidic or basic solution shows no change in color of blue or red litmus paper. Clear?